السلام عليكم. حياكم الله في اللقاء السادس من مجموعة الشرقية داتا جيكس. كما عودناكم في كل لقاء نتحدث عن جانب من جوانب علم البيانات. اليوم راح نتكلم عن جانب مهم وهو حماية البيانات أو خصوصية البيانات، داتا بروتكشن. متحدث اليوم الدكتور محمد فلمبان. دكتور محمد is assistant professor جامعة الملك فهد لبترول المعادن، وخريج حاصل على شهادة دكتوراه من جامعة بيردو يونيفرسيتي. Please welcome دكتور محمد.
السلام عليكم. أول شيء أنا شريف إني أتواجد معكم في هذه الجلسة الرائعة، وأشكركم جميعا على الحضور، وشكر خاص للمنظمين خالد حسين ودكتور عبد الرحمن. So excuse me, now I will switch into English. It's easier to present the topic. So tonight's talk is data protection and data science, challenges and solutions. So I'll take you over a brief outline for today's talk. So I'll introduce what is data protection. I'll talk about definition of data science, what I mean by data science. And then I will talk about the impact of data protection on data science. What is the impact of the regulations and the laws, and what is how to preserve the privacy. In the same time, how to make effective data science. Then we'll list some privacy solutions. Okay? I will go through some applications. So first of all, let's start with the data protection regulation. This is a new regulation that has been out in the last May. Probably you have noticed that whenever you get on a website, you will get a privacy message, or like a message saying we have updated our privacy policy. Right? So this is actually as a result of the what is called General Data Protection Regulation, which was put by the European Union last May, which has a certain list of regulation. One of them is plain language. So now no more buffering privacy agreements. It's already simple language, right? So in a couple of sentences, you can understand what is the rights, your rights, as well as the what is the website is doing with your own data. Okay. User consent. Now, users have to approve the usage of data. Right? So the company need to take the user's consent in order to collect, store, process your own data. Now, companies are mandated to allow the users to download your own data. So basically, now you are the owner of your own data. And probably you have seen this in Facebook. Now you have the option to go into your Facebook page, download your full profile, okay? Which is a good thing. Now you can do your own data science on your own data in an easy way. The GDPR also mandates companies to inform affected users in case of any data breach, any security problem immediately. And actually, they gave 72 hours in order to inform any affected users. Now they have company should provide the forget option, meaning if a user choose to opt out from the application, with a single click, you will delete all your own data from their systems. Finally, there should be some special safeguards on sensitive information or sensitive data. Okay, we'll talk about what constitutes sensitive data. Now, companies started to take this very seriously. The reason is they have a penalty of about 20 billion euros, or 20 million euros, sorry, or about 4% of their annual global income, whichever is the max. So that's why tech companies are taking it really seriously, and they've started to improve their privacy policies and the way they deal with data, which is a good thing for us as users. But on the other hand, for data scientists, this means a lot of things, right? But before jumping into that, let's kind of agree on what is the definition of a data science. I was myself confused how to define a data science in a proper way. I found this diagram and I liked it. So it's to me it shows that data science is a marriage of 3 different disciplines: math, statistics, computer science, domain and business experts. Right. So if you see that data science is kind of the intersection of them all. And the funny thing is that everybody or in every discipline they try to claim data science as their own. Okay, but it's actually kind of the intersection of all the 3 fields. But in order to understand again what is data science as a data scientist, I can concisely summarize the data science in 4 functions: data analysis, which includes processing or collecting data, filtering data, cleaning it, right? Extract some patterns, simple patterns from data. Statistical analysis, right? So you apply some statistical models like regression, extract probability distributions from data. So this is what is meant by statistical analysis. Then machine learning. So machine learning is kind of an application of data science, right? So you apply whatever statistical model patterns in order to extract some information, train your machine in order to perform certain jobs. Okay? For example, recommendation systems, which is kind of what movie to watch next on Netflix, or what item should I buy next on Amazon. So those kind of enabled by machine learning models. Final component is the data visualization, right? So once you have extracted patterns, create models, now you want to visualize it in a way that is appealing to the user in order to understand it visually. So to me, this constitutes the data science. Okay. Now, what is the effect of GTRP on data science? First, GTRP will limit the data processing and profiling on data, in a sense that now, as a data scientist, you are only required, or you can only perform certain processing on data with the purpose that is given to you. So, for example, if you are a health researcher, you can only take that data set, extract some health information or health knowledge. You cannot do it for financial reason, and vice versa, right? So GDRP kind of limit the data scientist in order to use the data set for the purpose it was given to you. Bias and discrimination. Now GDRP mandates that, actually it's GDPR, sorry. GDPR mandates that data should not be used in a discriminating manner. So meaning your output of whatever model should not discriminate between individuals in terms of race, religion, etc. Okay, so it should be biased to all this discrimination. Your decision the decision out of the models and the operation should be explainable. Meaning, if somebody came and asked you why did your model decided this way, you should explain that. Okay, and this is maybe bad news for deep learning advocates because nobody knows how deep learning actually works. So you cannot actually explain why your deep learning model performed this decision rather than makes this decision rather than the other. And the last one is the nightmare of all, which is less data. So applying all this GDPR regulations will reduce the amount of data or useful data, let's say, for data scientists. For one reason or the other. Maybe some users are reluctant now to share their own personal data with you, right? So now you have less number of data, less amount of data or useful data. Now, this is my understanding of data privacy. It's an intersection between data security and data privacy. And there is a difference between the two terminologies. They are not the same, although most people, they're using it interchangeably. So data security concerns about the collection, the processing, and transmission of data in a secure way, right? In a way that does not expose the confidentiality of data.
By confidentiality, I mean no unauthorized user can access that data. Okay. Also, preserving the integrity of data, meaning only the data should be reliable and correct all the time. The third dimension of data security is the availability, meaning that whenever I want to use or process the data, I should be able to do so, right? And this definition is different than the definition of availability in high-performance computing or database community, where they concern about the throughput and efficiency of their systems. And from the security point of view, think about it as this. For example, if you have a real-time mission-critical system where you need to make a decision on the fly, you need to process some data, right? So if you are not able to access this data, then you can make the wrong decision, which gives or which can makes very bad security consequences. Now, on the other hand, we have the data privacy. Now, there is some overlap between the two concepts or the two fields. In data privacy, it concerns about the anonymity, about the individuals and the data, right? Now, anonymity can be equivalent to confidentiality, but mainly data privacy is concerned about individual or human information. In security, there might be information about machines, right? So nobody cares if we expose some information about a machine. There is no privacy concept there. But it is actually critical if we reveal some information about an individual, his age, his health record. So this is what we call by what we mean by anonymity. The other aspect is collection and use limitation. Okay, so you are only required, or you can only collect certain amount of data, use it in a specific way. Data quality, which is almost also similar to data integrity, the data quality has to be always up to date, right? If somebody, let's say somebody got married, you cannot use his data before marriage. This is just an example. Control aggregation, you cannot combine data sets from different sources. You cannot combine health data with financial data, with social network data, and so on, right? So you are limited to data set that help your purpose, right? So please, if you have any question, just feel free to interrupt me anytime. That's a good question. So I will actually touch upon this anonymity concern in just the next slide. Okay. So now we understand what is the data protection, security, and privacy. Now in this talk or tonight, I'm gonna focus on data privacy. I'm sure that data security has you all know what are the countermeasures of that preserve the security of data. Okay, so I'm not gonna talk about any solutions for data security. Rather, I will just focus on the data privacy. So there are some solutions out there, either from the academia or from the industry, in order to preserve the privacy of individuals. Now, to answer Dr. Abdurrahman's question, what do I mean by anonymity, right? Basically, if you have a data set that contains any personal information, right, that is kind of, I will call that private information. If I remove that information from the data set, right, then that is called anonymous data, meaning I don't know which information this, or which individual does this information belong to. Okay, so this is what I mean by anonymous. Now, anonymous can be for the data scientist, can be for the data curator, the one who collects data, right? Or can be for the whole application. So nobody knows which individual this information belongs to. Okay. So now let me give you a scenario. Suppose that you are you work in a hospital and you want to share some health data with a researcher. Now, but you are concerned about the privacy of your patients. Okay. So the first solution comes to mind is to remove the personally identifying information, PIIs. PIIs can be name, can be ID, can be phone number, whatever is that. Can be his email, right? So then you think that this is enough to preserve the privacy of your patients. Now, is this enough? Well, history tells us that no, this is not enough. And there are two incidents that support this answer. Who knows Netflix prize or Netflix dataset? So Netflix prize is a contest that was released by or launched by Netflix back in 2006, I believe. And they have a prize of $1 million for researchers to beat their own recommendation system. It was called Cinematch at that time. Okay, and in fact, in 2009, there was a research group who won that prize. But that is not the point. The point is, back in 2008 or 7, a group of in the University of Texas Austin was able to identify some users, okay, by correlating their recommendation pattern with another website called IMDb. So for those who don't know IMDb, IMDb is a famous website for rating movies. So by simple correlating between the anonymous data Netflix has released and publicly available data, they were able to identify some users. Another incident is which was very political, causes some political problems, is the re-identification of the medical health of Massachusetts State health records. So a professor at Harvard University was able to find re-identify his health record from anonymous health data set by correlating it with publicly available voting data, right? She bought it for $25. She was able to re-identify his medical records, and ironically, she sent it by email. She sent it to him, and it caused so many problems. And actually, in another study, the professor runs a data privacy lab at Harvard University. She did another study where she was able to identify the names of more than 40% of the participants in a very high-profile DNA study. So this just tells you that simply removing, person names or IDs is not enough. So what is the solution? Simply, or the same professor has proposed this solution. Now, suppose that you have this dataset, health record dataset, right? In the green attributes are what we call identifiers. Okay, so we can identify a person using his age and zip code. The attribute in the red, in red, is the kind of what is called sensitive attribute. So it's the disease that he has or the diagnosis he has. And the solution is simply by grouping number of patients, right, into special type of groups and changing the values in the age and zip code, right? Now we will not be able to identify certain individuals. So let's say, for example, as a background, you know that Bob, let's say, is in his 20s, and he lives in a region the zip code starts with 130. So right away, you know that Bob lives is in this group 1, right? Now there are two values in the diagnosis, which is heart disease and viral infection. So now you have a probability 50% probability that Bob has either heart disease or viral infection. So in a way that you kind of improved his privacy, right? So you don't know now, as an adversary, as a bad guy, who knows that information, you don't know if Bob certainly has heart disease or viral infection. Okay. Now this is not enough. Why? Because suppose that in the diagnosis there are all the values in this sensitive attribute is heart disease, right? So even with the anonymization, if you know that your guy is in his 20s and lives in this region, there is 100% probability that he has a heart disease. So we didn't achieve anything. So another extension of this algorithm is called L diversity, and that mandates there must be L distinct values in this group for the sensitive attribute. So I'm not going to go over this detail. This research has been going for the last maybe 5-6 years. But if you are interested, just let me know. Yes.
Wouldn't this kind of anonymization defeat the purpose of making this data useful?
Good question. So he was asking is this defeating the purpose of data science? Yes, that is true. It is defeating. So in a sense that you are reducing what I call utility of the data, right? So your data is no more kind of useful in a sense. But on the other hand, you are preserving the privacy of your patients. So it's kind of trade-off between privacy and utility. There is kind of this research going on in kind of striking the sweet spot of this trade-off. What is the best way to achieve privacy and at the same time the maximum data utility? Right? So this is a very good question. Now, if you don't understand this process, let me explain it in another application or in another format. Now, suppose that you have geoinformation data. You are in your Google Maps. You are asking Google, what are the restaurants within 1 mile of my location? Now, of course, you have to upload your exact location in order to get the answer, right? So now suppose that there is an evil guy waiting for your response in the server. Now he knows your exact location, right? So now you are allowing the bad guys in order to track your movements, right? So applying the same concept of data anonymization, rather than giving the same or the exact address, the application will take a kind of a larger area that includes your location as well as other users, right? In a sense that I will give your location and increase the radius, let's say 100 meters, 1 kilometers to include other users. Now the bad guy will see that, oh, you live in this or you are in this region, but there are other 3 users, active users. So which one is you? He doesn't know. So this is kind of another same concept of anonymization, but in another application, geoinformatic or geoinformation systems. Okay. Now, this sorry, yeah.
Yeah, question. Does this anonymization process happen on the device before it is sent out to server, or I don't know, in the back end?
That's a good question. So what I didn't mention is that this data, okay, I'll come to your question, but let me explain this. This data set is what we call it published data. So it's already published online. So you have to anonymize it and then publish it for data scientists to use it. Now in this happens on real time, right? So the application will take your exact location, increase the area to include other active users, and then send it back to the untrusted server. Okay. Now all this kind of privacy solutions are happening to the data, right? Now I want to take you to another approach, right? Which is kind of related, more relevant to machine learning models. Now I'm sure that all of you knows what is machine learning, right? So basically they are mathematical models, either supervised or unsupervised, in order to answer some questions, right? So for example, in the classification, you have 2 types of data, the red triangles and blue circles. The machine learning model would draw a line separating the 2 types, right? So it's, at the end, it's a mathematical model. Same is for regression. What you want is to kind of draw a line that connects the dots. Clustering is the same. You just want to group similar points together, right? Now, again, all those are mathematical models. How do you train those models? Using some training data, right? So training data might have some private information or sensitive information. Now, do you think this, by building a machine learning, you kind of preserve the privacy of the users? Well, you're wrong, because hackers are very smart. They have all kind of reverse engineering in order to get whatever private information in the training data. So they came up with what is called reconstruction attacks. They take the features in your model, they reconstruct the features in order to get the training data, get the private information embedded in the data. They can do model inversion. So if there are new features, they can take your model, reverse engineer it, get the training data. And all those are real attacks. Okay, and in order to address this problem, there are a number of privacy-preserving machine learning models. So if you simply go into Google Scholar and just type privacy-preserving machine learning, you'll get privacy-preserving SVM, privacy-preserving deep learning, privacy-preserving association rule mining, privacy-preserving distributed clustering, decision tree, etc., and so on. Okay, so this problem is real, and it has been addressed in academia. I'm going to summarize it for you in along 2 dimensions, or I'm going to summarize all the techniques in two main techniques. The first one is homomorphic encryption. The second one is differential privacy, and I believe that differential privacy is kind of will get into the standard way to preserve the privacy of users and consumers. But let's jump into homomorphic encryption. So typically, an encryption will an encryption basically, if you want to send data into another party, you will agree on a secret key, right? Then you will apply some encryption function on your data, send it to the other party. The other party will use the secret key in order to decrypt it, and then do the processing, and then they will send the result in the same way. Okay. With homomorphic cryptography, you don't have to do that. Then this is the magic of homomorphic cryptography. In a sense that if you want to say, create a tax report out of your pay slips, what you're going to do is you're going to encrypt your input, encrypt your data, send it to the untrusted server, right? So the untrusted server, there are some bad guys waiting for your data in order to steal it. But what homomorphic allows is they allow evaluation and processing on encrypted data. Okay, so they do their own magic on the encrypted data. Once the processing is done, they will send the encrypted response. When you get it, you just need to decrypt it, and then you get your results. Okay, so in other words, homomorphic cryptography allows the processing and performing certain operations on encrypted data without decrypting it. Okay, so now if this sounds kind of science fiction, it's actually in practice. So there are companies that is using homomorphic encryption for secure voting, right? So the idea is that you send your own encrypted vote to the untrusted server or to the server, and they cast all your votes while preserving your privacy, okay, and confidentiality of the data. And I think I forgot which state in the US, but there is a company called eBallot who is using the same concept. Another application is kind of secure MRI. Okay, so MRI in hospitals are very expensive, and one of the most expensive parts is the data, is the chip that does the data processing. So in order to reduce cost, what they're proposing is they just sell the the parts that take the images, and they offload it to the cloud, encrypted, of course. It does the process there and then send it back, okay, in order to reduce the cost. So now a hospital can have many MRIs without data processing kind of functionality. All the functionality is done on the cloud, but the data sent back and forth will be sent in an encrypted way. Okay, so this is another application of homomorphic cryptography. Now I come to the differential privacy. Now this is one of the important concepts in privacy, and it's already seen. The application is already there. When I started to work in differential privacy back in 2012, it was only theoretical model. But now I will show you like there is one application that is actually using differential privacy. And the idea here is simple. Suppose that there are two databases, okay? One with 3 users, including Bob, and another database without Bob, okay? And then you ask a question. Select is a database in database language, meaning give me the number of people in their 20s and diagnosed with cancer, okay? Now, if the bad guy knows that Bob is in his 20s, okay, and he received the answer of this query from the first database as 100, and from the other database as, sorry, it's supposed to be 99, okay? Then he knows that, oh, Bob has a cancer, okay? By this difference in the query results, now he can infer that Bob is in this database, okay? So we want to come up with a mechanism where the adversary doesn't know. So differential privacy is basically a randomized algorithm. Randomized algorithm meaning it uses some random variable to produce the results, okay? But now the question is, what is this randomized algorithm, okay? It turns out this is the kind of mechanism. I didn't want to add this, but I added just for the nerds among you to kind of feel happy. So this is the concept of differential privacy. What it's saying is that the adversary shouldn't distinguish if, by asking this question, the previous question, shouldn't distinguish if Bob is in this database or not. That is simply the idea, okay? And in order to do so, the system or the differentially private system will append a random variable at the result, right? And this random variable is kind of, it has its own specification. It has to be drawn from certain probability distribution. By doing so, now if this adversary got this results, he wouldn't know if Bob is in that database or not. And then you can't generalize it. Rather than Bob, take everybody in the database, right? You differentially do the same thing, and then you kind of conceptually you're preserving the privacy of each individual in that database. Okay, so this is the idea or the concept behind differential privacy. Now, if you have an iPhone, you're already using that. So Apple, and I think it's in their 2 updates, I think starting from iOS 10, they are using differential privacy to get information from your interaction with iPhone in order to improve the services. And specifically, they improve the quick tap suggestions, emoji suggestions, lookup hints, etc. Okay, so they are collecting this data using differential privacy in order to preserve your privacy. Okay. Now, this is my opinion of the impact on data security on data science. Now, if you apply countermeasures for the confidentiality, right, then you will get harmed as he was mentioning. It will defeat the purpose of data science. So you will not kind of do effective data analysis. You will not perform effective statistical analysis, machine learning, data visualization. And the reason is that because you are kind of limiting the utility of the data. The same goes for the privacy. But now in terms of privacy, it is more kind of severe, right? So if you preserve the anonymity of individual in the data set, you kind of have very like you harmed your own analysis, data analysis, statistical analysis on the data. Okay, so to summarize, I think more data protection laws are coming in the next few days or next few years, and already California state has a motion for a Privacy Act motion, which gonna be effective, I think, by next year. I think Australia has the same thing. Nobody wants to pay $20 million as a fee of breaching the privacy, right? So now companies, tech giants, are kind of taking it seriously and pushing toward preserving more privacy of their consumers and customers. So those are the solutions. Of course, I didn't list them all. This is kind of just scratching the surface of privacy preserving solutions. But in a nutshell, we can categorize them as data oriented. So you take the data set, do your own processing, anonymization, and then publish it for data scientists in a way that does not reveal any private information. It can be model oriented, basically designing a privacy preserving machine learning model that preserve the privacy of your individuals. Or it can be cryptic based, right? With homomorphic encryption, this is kind of enabling the preservation of the privacy. Okay. Before I end, I'll just give you a brief about myself. I got my bachelor from KFFM in 2008. I got my master's degree from KAUST in 2011. And I kind of spent the summer in working in IBM TJ Watson lab. And I just got my PhD degree back in last March of this year. And now I joined CE department at KFUPM as an assistant professor. This is my research interest. I'm interested in building cyber resilient systems, specifically doing cyber resilient Internet of Things in terms of cloud edge and cloud computing. I'm also interested in data privacy and security. Actually, my thesis was in designing database intrusion management. I'm also interested in general on privacy preserving big data analytics. So I've been working on privacy preserving hidden Markov models, and I'm expecting some publication to be out soon. I'm also interested in learning-based collaborative video streaming systems. And these are some of the current projects that I'm working on those days. And with this, I conclude my presentation. I think I was fast. Thank you again for listening. Right.
Could that have a positive effect somehow?
In terms of data science? Privacy?
I mean, for example, the statistical model.
Okay.
The data privacy measures improve the accuracy of my model, for example, somehow.
This is unintuitive. I believe the privacy will harm the statistical models. Right. So your question is, does the privacy improve their statistical modeling? I don't think so. Most of the work I've seen, they have this kind of error when working on anonymized data. So it's definitely harming. They're not useful. Any other question?
أنا عندي سؤال.
Just maybe not a question, but presentation. You actually show a very important point. People in information data science, people now they care about acquiring data and analyzing data. There is a business how to get the data, how to set the data. And it happened by chance. Like some people, they talk to me about how this can be a business, how to get the data, because you
Right.
surprise that some manufacturers, some companies, sometimes they manufacture some products and they don't have the real data about their product.
Right.
And other people, and this we found in people in the cloud and other business that I'm not going to discuss. But what you discuss here is one business that maybe nobody noticed it, and now which is if the data was encrypted or if there was a privacy, and how can, even if it's there are some privacy involved in the data, how can I reveal the real data? Whether, of course, this business is legitimate or legal or not, this is another story. But you said that how some people they were
Okay.
And how if people hide the data, how we can expose it.
You are right, yes. So in a sense that those privacy solution or sophisticated one will actually lead to more data sets to be released to researchers, right? So I talked about one of the concern of data protection is reducing the amount of data. But with correct, with let's say proper privacy techniques, yes, that will increase the number of data sets. And actually I remember that one of the companies, transportation companies in Saudi Arabia, they have a huge data set, and they were reluctant to share that, mainly because of the privacy. Right? It was involving kind of information about children, about women, so they were very reluctant. So I think enabling or having such privacy solutions will allow them to kind of release this valuable data sets.
So, is there existing tools that help?
Yes, I failed to mention. In terms of data anonymization, there is a website that provides an online way to perform that anonymization. So it's called ARX. If you are interested, it has they have implemented many algorithms. So if you let's say you have a data set that you want to release, and you're concerned about privacy, you can use their own tool, do your anonymization, whatever algorithm, and just publish. You can download. I think it's a jar file. You can download it in your own machine. You can just run the algorithm.
Is there some sort of benchmark or measurement that shows that, okay, I am now anonymizing the data, but what's the loss of usefulness?
Okay. Yes. Very good question, actually. Definition of utility is kind of vague, right? So until now, there is no single definition of utility of data. So even if you apply your privacy, you cannot really measure what is the what loss that you are what is the utility loss. Okay.
For a specific purpose.
Exactly. So you have to kind of define your purpose, your own definition of utility, and then measure it. So let me give you an example. If for example, health record. If you are anonymizing information like phones, emails, then the utility is still high. But if you are anonymizing other vital information, physiological information, then you're losing a lot. So it all depends on the purpose. What do you want to extract from the data set? Okay. Have two questions there.
Regarding the GDPR law, does it go to impact, for example, Google services,
Yes.
free services?
Yes. So although it is from European Union, the regulation is is effective only on European consumers, right? But but now the companies are really worried that they have applied it to all consumers around the world, even in Middle East. So yes, it will affect almost all the services, all the tech giants, including Google, Apple, Facebook, name it. I think you had a question.
Well, Majid kind of spawned my question, but it was about the effect of GDPR on Saudi Arabia products. Like if I want to build a product locally for Saudi Arabia, is it going, or for the Middle East, is it going to be affected by?
Okay, so I don't. Yeah, but again, there is there is a point, and I'm not sure about the legalities here, and I'm not law person, but if you had a European consumer, then yes, you're in trouble. If you don't have any European consumers, then you are fine. You can't breach whatever privacy you want.
I think that's why almost all the websites now they have this permission to cookies, even though because they don't know the client and
Exactly.
the user if you're European or not.
Exactly.
So even though it's applied only to European entities, even the user fee is
Right. So they play it safe. Yeah.
That's why almost all the websites now they
Yeah. That's correct.
What if he's European, he's expat, he's working here?
So he's a European consumer.
He consider
Yeah. He's a European passport. I think. Allah يعافيك إن شاء الله.